Hey everyone, hello and welcome to today's webinar. Apologies for starting just a few minutes late. We really appreciate you being here. We're excited to get started. Let's go ahead and dive in. So today's webinar is on indoor drones, case studies, and best practices from the field. This is part of an ongoing webinar series we've done. There's 6 webinars total in the series. We've already covered the benefits of drone inspections in the first webinar. The second webinar was on insourcing and outsourcing. We had Nick, who's here again today, present with us last time. And today we're going to be diving even deeper, drilling down, looking at indoor drone applications specifically. So one thing to note, we're doing this webinar series in partnership with MFE. MFE is a provider of robotic solutions, including drones, including Flyability's Elios 2. They have a lot of other solutions as well, and we're excited to have partnered with them on this series. So today I'll be both your moderator and one of your panelists. I'll be presenting today, talking about case studies that I've helped create. My name is Zach Dukowitz. I'm the content marketing manager here at Flyability. We also have Nick Harwood on. He's the Unmanned Systems Operation Manager at Mistras Group Incorporated. A quick note, a few housekeeping items as we get started. Make sure to ask questions. If you are curious about something, if there's something that you want to know, make sure that you use the questions pane. You go ahead and get in there, right? So if you have a question, just go ahead and type it in as it comes in. We won't be able to answer most questions live, but we will be archiving those questions and saving them in a Google Doc so that we can answer them during the live Q&A. Another note, we get this question a lot. People ask if we are recording the webinar. The answer is yes, we are recording the webinar. The recording will be available afterward. So if you miss something or if you want to share it with a colleague, you'll have that recording. So today's agenda, just to give you a sense of what we're going to be covering today. Right now we're doing the intro. That's about 5 minutes. The bulk of the presentation today is going to be Nick and I talking about indoor drone inspections, looking at case studies, best practices from the field. We're also going to be going over assets, industries that use indoor drones for internal inspections. And Nick's going to kick us off with some things to consider for indoor inspections. We'll get to that in just a moment. So just to do some intros, kind of tell you who your speakers are. Nick has an extensive background in inspections. He's the founder of Atex Group Incorporated, which is a drone services company that was acquired by Mistras and then spun into the Unmanned Systems Center of Excellence at Mistras, which Nick heads. Nick's worked as a consultant, an integrator, and service provider for drones and robotic solutions in the petrochemical industry and in the oil and gas industry for several years. In that work, he's helped provide cutting-edge technological expertise and sustainability plans for inspection data gathering so that industry leaders can focus on their core competencies. He's got a wealth of knowledge to draw from when talking about using remote visual inspection tools, or RVI, an acronym you're going to hear a fair amount today, including indoor drones. And Nick's going to be sharing insights from all of his experience with us today. So we're really excited to have him. And then I'll be your other presenter today. Again, my name's Zach. I'm the content marketing manager here at Flyability, and I've been working in the drone industry as a writer and a reporter since 2016. In my work at Flyability, I do a lot of writing. I write case studies, some of which I'll be sharing with you guys today. I also write articles, press releases, guides to drones and non-destructive testing methods, and I also head up our webinar efforts. In addition to all my work at Flyability, I'm a contributing writer at UAV Coach, where I've written hundreds of articles about the drone industry over the last several years. So here is an overview of what we're going to be covering today. We're going to start with an overview of indoor inspections in general. We're going to look at assets and industries that have indoor inspection needs. We're going to look at case studies for indoor drones and also best practices. So I'm going to go ahead and hand things over to Nick right now. So I'm going to hop off my camera for the next few minutes.
Thanks a lot, Zach. Hey, everyone. And yeah, thanks a lot for including me, guys. Flyability, MFE. It's good to be a part of this. So yeah, so the first thing we'll cover here in the first part, just at a high level, are just the basics to lead into some of our great case studies that Zach has put together. So the first question we want to answer is what is an indoor inspection? Since that's kind of what we're focusing on here, indoor inspection as it relates to visual inspection primarily is the focus here. And that's any inspection that occurs indoors, obviously, right? And so actually, Zach, do I have control of the slides or do you? Sorry.
No worries. I have control, and yeah, just let me know and I can move it along.
Okay, cool. Yeah, go ahead and move to the next one there. And we can go on to the next one as well. Yeah, cool. So with an indoor inspection being anything indoors, obviously, we want to kind of distinguish between the indoor drone and indoor inspection technology versus an outdoor external inspection drone technology. There's a few key differences. And the other thing that we'll come around to later is with respect to what we're considering an indoor inspection are also inspections that occur in kind of tight spaces, maybe outdoor, but it can occur in tight spaces as well, where indoor drone technology can help us there as well. Zach has some more details on that later on. But the key distinctions that we make between an indoor drone and an outdoor drone per se is that the indoor drone is able to fly in a GPS denied environment. There are a lot of drones out there today that can do that, but there's a few further clarifications that we want to make when choosing the right indoor drone technology. Drones like the Elios 2 have the protective cage around them, which is key because that's going to offer us collision protection and allow us access to very difficult areas, which will provide a ton of value when doing internal inspections. I mean, go ahead to the next slide, Zach. The other key, go back one. Yeah, the other key there is you can also see the integrated lighting, very important, with the goal here being we're doing an internal inspection where we have not sent people yet. We don't want to send people, so more than likely it's very dark, and so that internal controllable lighting is very important as well. We can go on to the next one. So for the scope of this conversation, we're primarily talking about RVI or remote visual inspection. There's a lot of inspections and non-destructive testing that occur internally to structure, but for the scope of this conversation, with respect to the capabilities on the Elios 2 and other robotic platforms, we're just going to talk about the visual portion. And when choosing the right tool for your RVI inspection, we've talked about this in the last webinar. I think it's mentioned many times, but it really is all about the data. The drone is just one type of tool to help us get that data, but there's tons of different RVI tools out there, and there might be another tool that's better fit. We'll talk more about that at the end in the best practices section, but you've got anything from crawlers that attach to surfaces, long-range pipe crawlers, and even drop camera systems. So on to the next one. The tradition, what we're trying to make more efficient, what we're trying to minimize in a lot of ways, at least for our initial screen, is the need for traditional access methods like you see here. Traditionally, depending on the type of asset that we are inspecting, you might in most cases, you're dealing with a confined space entry. For a lot of the applications that we talk about later on, they do require a confined space entry, which takes a ton of planning, a lot of personnel, emergency personnel, and of course, inherent danger associated with that. In a lot of cases, there's also scaffolding involved, which is very expensive. And in other instances, you have rope access potentially. All of those can be great cost. They take a lot of time comparatively. And the goal of this is to make all of that more efficient. And the Elios 2 does a great job. Moving on, Zach. And so the benefits that we're focusing on is, of course, the big one at the top is savings. You're able to see savings across the board in many different ways, which you'll see in the case studies, from reduced scaffolding, downtimes and work hours. Safety, the big thing that we see by using RVI technologies is that we're reducing exposure hours in a big way. And then we're also reducing downtimes for our clients. So obviously, a lot of our clients, if you're at a production facility, if that facility is not producing, they're not making revenue. So that by reducing downtimes, it goes all the way back to the top to the savings argument. They're able to see massive savings by using RVI technologies. On to the next, yep. Cool, so when it comes to indoor inspections, what should we consider from a regulatory standpoint? At least in the United States, and I believe this is fairly common throughout the world, but whereas external or outdoor inspections require a commercial license, the indoor inspections do not require that same license. They're not governed by a federal authority that controls airspace because, at least in my experience, there haven't been a whole lot of airline traffic going through pressure vessels and tanks. And so they don't control the airspace within your tanks and vessels and boilers and things like that. However, it's worth noting that it is good. We think that in general that that training is good to have. We'll talk more about that in a bit, but it's also worth checking your local federal requirements before diving in as well.
Oh, and just a quick note, you'll see there's a logo up here on the slide for Drone Pilot Ground School. That's a course. It's an online course if you have pilots who are getting ready for the Part 107 test. It's a very involved test. There's a lot of knowledge you need to know. And if you're looking for support, Drone Pilot Ground School is an example of a course you can get for your pilots, pretty inexpensive to help them prepare. I think Nick at Mistras, they use Dart drones. That's another example of a high quality Part 107 test prep course. And I would imagine in other countries that have similar regulatory frameworks that you could find similar resources where you might have to pay, $100 US, $200 US, but it's usually well worth what you get in terms of prepping your pilots so that when they walk into whatever the test is, they pass it the first time. So I just want to do just a quick note on Part 107 test prep. It's something over at UAV Coach, which owns Drone Pilot Ground School, for transparency. Something that I've written about a lot is, prepping for that test. But I'll let you continue, Nick. Thanks.
Cool. Yeah, thanks. And so that's a note on the regulatory considerations. But to take that a step further, it's one thing to have your regulatory certification. It's one thing to buy your drone, have your drone, and just pick it up and go for it. But we strongly believe that the trainings that are offered out there are valuable, and there's a few different ways that you can go about getting specific training on various technologies, especially the Elios 2, if you plan to insource. So there are several in-person training options where you can go to a classroom, get in-person hands-on training. You've got self-training options on the Flyability website per the link there. And then a lot of service providers even take that a step further. They'll do one of those programs and in addition have their own internal training program as well. So as far as when you're scoping out your project, again, going back to the line, it's all about the data. Well, it really is. So when either looking internally or looking out to service providers to provide this internal inspection for you, it isn't about using the drone for the inspection. It's not, the inspection isn't about flying a cool drone around. It's about getting certain data and providing some sort of actionable report or answers based on that data. So you have to ask yourself, do you want a service provider that uses drones, or do you want to use the drone internally? And do you have an inspector to go with that, or an SME? So you could have, for a certain internal inspection, if it's an API tank or API vessel, let's say, more than likely you'll require an API inspector. If you're inspecting welds, you may require a certified weld inspector. That person could be the pilot, or you could have a crew where you have your highly trained pilot and you have that inspector next to the pilot, essentially directing the operation with his own screen, doing that live inspection, just as if he were inside the vessel per traditional means. So with that, I'll turn it over to Zach, and he's got some really good examples of all of these applications. That was just a real high-level overview, but let's get into specifics, Zach.
Awesome. Thanks so much, Nick. And one thing I'll mention, Nick told me this when we were first getting to know each other. If you are just like a service provider in general that works with drones and you wanted to get into inspections, it is not impossible, but it is challenging. And this is related to what Nick was just talking about. Nick himself started as a general service provider doing, aerial photography, all those things that you might do as a drone service provider, and wanted to get into inspections and realized that to do so we're going to require a lot of specialization. And he did it really successfully. Obviously, he started an organization that was acquired by a huge inspection company. So he has a lot of knowledge about that. If that's something you were curious about, going down that road, he would be a great resource. And we'll be sharing his contact information a little bit later in the presentation. All that being said, let's go on. We're going to be looking at assets and industries, and then I'm going to be talking over some case studies for indoor inspections. So to make things concrete, when we're talking about how indoor drones are used in internal inspections, let's look at some examples of places where you might need to do those kinds of inspections. So the most common assets that we see are boilers, pressure vessels, stacks, and tanks. These are all industrial assets that require some kind of transitional downtime. You can't use them, obviously, when you put a drone in there or a person for inspection purposes. We also see sewer systems, mines, grain bins. Those are also some pretty common places where indoor drones are helpful with internal inspections. And you see some pictures up here showing you examples. Some less common assets, and these are interesting. Bridges and factory ceilings, if you wanted to get up into the joists and the beams in the top of a factory ceiling and see what's going on. Dams are another place where we're seeing a lot of indoor drone use starting to grow. After fires in public safety, either for police or for firefighters. So if you have a burned out building or you have an unstable situation, sending an indoor drone in to get visual data on what's actually going on in there. And then the last one is pretty fun and kind of interesting. Amusement parks, amusement park rides, water park rides. So it's similar to bridges and factory ceilings. You're looking at all the supporting structures, right? So it's really hard to get up under there and see what the condition is of those kinds of things. So all of these are examples of less common assets where you see indoor drone use, but they kind of help you realize that if you have a use case where you suspect that an indoor drone could be useful, it probably would be useful. I certainly haven't exhausted all of the different kinds of ways that I've seen our indoor drone technology be used. These are just some of the top uses. Even the less common ones are still ones that I've seen. So if you can imagine it, we could probably help you do it. And then some industries. So this is just a quick list. The most common industries where we see the Elios 2 used are oil and gas, power generation, mining, chemicals, and also maritime. And maritime is usually some kind of storage container or tank. You can imagine any internal scenario where you need to do an inspection to understand the sort of condition inside that container. We see growing adoption in, again, sewer or wastewater infrastructure. Food, beverage, and agriculture, and a grain bin would be an example of the type of asset in that industry. But also we see like processing plants. There's all kinds of nooks and crannies where it's hard to get in there and actually see what's going on. An indoor drone can help you get access. Public safety, again, we actually had a really unusual, interesting case recently that I got to write about. The Marseille firefighters are using drones, testing our drone technology to go into boats that are in trouble so they can evaluate the risks for sending in manned firefighters to fight a fire, decide whether the fire can be put out, try to locate people that are in need of rescue. So there's some really interesting public safety use cases that we're starting to see. And then finally in infrastructure, again, bridge inspections. I got to recently write about a railroad bridge inspection on the Trans-Siberian Railway, where because it's part of the railway, the bridge is constantly in use, so you can't shut it down to inspect it. A drone was an obvious solution, and the Elios 2 ended up being really helpful for them to get visual data on the condition of the bridge. So all that being said, let's dive into some case studies. So I'm going to be talking over just several case studies that I've helped create over the last few years, talking to different people using indoor drone technology. So the first one is in oil and gas, and I'm basically going to be going through those primary industries I already mentioned. We didn't have a good example in chemicals, so that won't be included. We have a few examples in power generation, but you'll see I've tried to create sort of a variety of assets, a variety of use cases. So the first one is oil and gas. This was actually here, well, not here, I'm actually working from the US, but Flyability is based in Switzerland. So this one was in Geneva, Switzerland. There was an oil depot that has 17 different diesel tanks on site. They used the Elios 2 to inspect one of those diesel tanks, really as a test. And these diesel tanks were pretty old. They were built back in the 1960s. When they were built, they were only expected to last 50 years. Obviously, it's been more than that. So originally they were being inspected every 10 years, but given how old they are, those inspections have increased in frequency. Now they're being done about every 3 to 5 years. So to inspect this diesel tank, typically using manned inspection or direct visual data collection would require inspectors to stand on scaffolding at 65 feet or 20 meters high. And inspectors would have to wear explosimeters to detect the dangerous vapors that might be present in there and make sure that they're safe. But using the Elios 2, we were able to completely remove the need for inspectors to enter in order to collect visual data. So we improved safety, eliminated the need for standing on scaffolding and confined space entry. We also were able to realize a net savings per inspection of $35,000 US, which reduced the cost for the inspection by 96%. And then finally, the downtime was reduced significantly for the diesel tank inspection from 2 weeks to just 4 hours. So really significant time reduction. And that's a place where you, again, see a lot of savings, not just in the cost of the inspection, but in the amount of potential revenue lost. So another case study, the Tennessee Valley Authority, also called the TVA, tested the use of the Elios 2 for a scrubber inspection. The TVA has a pretty robust drone program. It's run by a guy named James Manny. He's presented before with us on how to build a drone program, and he's doing really impressive work. So the TVA has huge power generation operations. For this specific case study, the scrubber that they wanted to inspect, if you haven't heard of a scrubber, it's formally called a flue gas desulfurization unit. And it gets the name scrubber because it's used to scrub sulfuric emissions from the exhaust of coal-fired power plants. These things are huge. They stand at over 100 feet tall. They're 60 feet in diameter. It's just a huge area to cover if you're trying to collect visual data, you know, as a person, as an inspector walking around or standing on scaffolding. In order to collect visual data in there, you would have to stand on scaffolding at about 80 feet in the air or 24 meters high. But using the Elios 2, they were able to realize these primary outcomes. So they were able to get the work done much faster. So the time needed for the inspection was reduced from 480 hours to just 10 hours, a huge time reduction of 98%. Obviously, those safety elements, the need to stand on scaffolding was removed, the need to enter a confined space was removed. And then the overall improvement of maintenance, and this is, I'll have another one where there's a good spot check example, but the problem with needing to build scaffolding or temporary structures to get access to visual data is it removes the possibility to do spot checks. If you just quickly want to know how something's doing, you're not going to build expensive scaffolding, right? You're probably just going to hope it's okay. But with a drone, you can just go find out real quick. And James Manny, who runs the TVA program, told us that after this test, they were able to go back and just do a few quick spot checks to see how things were doing. So the improved maintenance aspect is that because you have the ability to collect visual data more quickly, you can identify developing issues more, earlier on and potentially address them. I do have a quick video of footage gathered during this mission, so I'm going to play that right now. Just give me one moment. And there's no sound in this video if you're wondering, but you'll see in just a moment the tiny little space that the drone's able to enter for collecting visual data. Okay, I'm going to call it there. I think that was plenty, just to give you guys a sense of what was collected, the kind of visual data that was collected during that inspection. So we have another power generation case study. This one is of a boiler at a power plant that was located in Argentina. And this is a really cool story. Again, this is a spot check story. So we were out there, not me personally, but someone from Flyability was out there at this power plant. It's called the Bahia Blanca power plant. It's one of the biggest power plants in Argentina. It's owned by Pampa Energia, a big power company, energy company in Argentina. Originally, the reason for the mission was to inspect one of the two boilers that were on site. But the first inspection, really the only inspection scheduled for the day, only took 20 minutes. And inspectors there were really surprised and pleased. Usually that inspection would have taken 7 days, primarily because they have to build scaffolding, take it back down. So in 20 minutes, they got all the visual data they needed. So our representative from Flyability was having lunch with the Pampa Energia team, and someone on the team said, well, hey, we have the second boiler already cooled down. Why don't we do a quick flight in there? When they flew into the second boiler, they discovered that several of the burners were wasted, as you can see in the picture that's up here. They were surprised by this. The boiler was not even 2 years old, but it was actually so badly damaged that they didn't feel safe turning it back on after they discovered this. So a great example of, you have the technology, let's just go in and see what's going on. And you discover something that could have actually presented big costs and safety issues really quickly, just because you can easily gather that visual data. So a total savings was realized from doing this sort of spot check flight that really, again, on the second flight, again, only took about 20 minutes, of $320,000. 30,000 was from not needing to build scaffolding, and 290,000 from the reduced downtime, right? 20 minutes is a lot shorter than 7 days, and that's a long time to have an asset like this offline. Safety is obvious here again, right? This is a pretty common way that we improve safety with indoor drones. You don't have to send a person into a confined space. You don't have to have a person on scaffolding. And the total downtime was reduced from 7 days to just 2. You did need some time to allow the boiler to cool down, right? So there, 2 days is the total like realistic time, but 20 minutes was the time once it's cooled down needed to collect the actual visual data. Mining. So we're going to move on. This one's pretty cool, and we have a cool video to go with this one as well. This wasn't a specific mission. We spent 3 days at the Barrick Golden Sunshine mine. It's owned by the Barrick Mining Company. Barrick Gold is the name of the company. It's a gold mine, and in mines in general, there's often a lack of visual data. After you blast and you create a cavity where you're trying to extract ore, you can't enter it. It's not safe, and the machinery typically used, the muckers that are used in mining, are very expensive. They can cost $100,000. So you don't want to just send one of those casually into an unstable place, but sending a drone in to collect visual data, see what's going on, turns out to be incredibly effective. So again, yeah, the traditional approach, previously I've said traditional approach, you send a person in, they look around. Here, you wouldn't even send that person in because it's just too unstable and too uncertain. So you have a situation where you kind of just don't know. But using the Elios 2, the company was able to realize some significant savings. Here, the savings weren't from not having to build scaffolding, but they were from actually finding more gold ore, because by sending in a flying camera, sending in a sophisticated flying camera, which is what an indoor drone really is at its heart, you're able to see if you're missing any opportunities to collect more ore. So they were able to find more ore and capture it, and they're also able to protect those expensive robotic systems, those muckers. They're also able to get access. So accessing visual data in parts of the mine that they really couldn't have gotten otherwise. And then they were able to improve safety. Just knowing more about what's happening in those stopes, those areas that have been blasted, allows for improved safety to know whether it's actually safe to enter an area or not. I have another quick video I'll play you guys for this one. Just to give you a sense, I think this one does have sound. It's kind of dramatic. So I'll go ahead and stop there, but the flight continues until the end of this tunnel. So there's about another minute of footage, but I don't think we need to actually look at it. But as you can see, you can get really up close visual data about what's happening, inside these blasted areas. Give me just one moment. I'll go back to the slides. There we go. Okay. So next case study is in maritime, and I mentioned already, in maritime, you're going to primarily be looking at storage containers, tanks. So this case study was an oil tanker, and this is a really interesting situation. Back at the beginning of quarantine, back in March of 2020, the beginning throughout the world for most of us of quarantine, the cost of renting an oil tanker shot up from 25,000 US a day to about 200,000. The reason for this was because oil prices had plummeted, and people in this time who know what they're doing in this space, they'll buy a lot of cheap oil, they'll buy it, store it on a tanker like this, and they'll literally float around until the price goes up, and then they cash in. And if you have enough quantity, you can make a lot of money just by sitting on the cheap gas. So this was an incredibly bad time to have your oil tanker offline. So this oil tanker management company, they noticed a crack that they were really worried about might force their tanker into dry dock, which would lead to 10 to 20 days of repairs and inspections and trying to figure out what's going on. So they wanted to do a quick inspection as quick as they could, figure out what the crack meant, like what the implications were for the tank that was holding the oil. And they're able to do so and save $2 million, primarily in avoiding extended downtimes for the tank. So let's look at the outcomes. Yeah, so the 2 million was saved. 400,000 was from just eliminating the need for scaffolding. These tanks are massive, so building scaffolding there and taking it down is just a huge operation. So $400,000 saved immediately just from avoiding that, but also 1.6 million from the reduced downtime. So it would have taken 10 days to do a manned inspection. It only took 2 days to do it with a drone. So those 8 days times 200,000 a day, 1.6 million realized for a total of 2 million realized. It was a unique moment, but a pretty crucial example of how this technology can be helpful in a pinch. Safety is obvious here, right? Eliminated the need for scaffolding, entering that confined space. And again, the downtime was reduced from 10 days to just 2. We have a quick video here as well to give you a sense of what they saw inside that tank to show you the crack. Give me just one moment. This is another one with no audio. And you can see that crack there, and they get up and close, you know, so they can better understand, you know, what might be happening structurally and sort of what the implications are going to be for the tank itself. Okay, we can go ahead and stop that there. I just have one more case study, and then I'm going to be handing things off to Nick to talk about best practices. So last one, this is again in power generation, but it's a very different kind of asset. It's a wind turbine inspection, and this one was really interesting. We just did this within the last 6 months. A company called Ørsted wanted to test the Elios 2 for inspecting wind turbine blades. Usually you have a person physically enter a wind turbine to look at the blades. Inspectors are only legally allowed to go a certain depth into the blade, which means that you don't get visual data on a pretty significant portion of the blade. So Ørsted wanted to see, can a drone go deeper? Can they collect more visual data? Can they do it more quickly? And what they found was, yes, a drone, the Elios 2, was able to get 40% more coverage of the blade, 40% deeper than a person would have been able to get. They were also able to cut the inspection time in half, reducing it by 50% using the Elios 2, and again, eliminated the need for that confined space entry, in this case, crawling into the blade. And this is the last one. I've just got a short video, give you a sense of what we saw in there, and then I'll be handing things off to Nick. Okay, cool. So yeah, I'm going to hand things off to Nick to talk to you about some best practices for indoor drone inspections. And yeah, Yeah, thanks so much. So there you go. Cool.
Awesome. Thanks, Zach. Cool. So you can go to the next slide. So we're calling this best practices, but I look at it as kind of a very high level work process when going into a remote visual inspection situation. So the process that we'll go through is at a high level, of course, due to time, we'll talk through job scoping, determining what the best technology is based on the scope, some things to consider when going through a risk analysis and your mitigation planning. We'll talk about the need for environmental and safety checks, and then the value of data validation. So moving on to job scoping. So again, I feel like a broken record on this, but it's all about the data. So it's really important to understand what data is needed. Is this a close visual or is it a general visual? And of course, we are focusing on remote visual only at this point. There are lots of technologies, remote technologies that can do ultrasonic thickness testing and phased array, eddy current, those types of things. But when it comes to visual, there's really two main types. It's close or general. And so a lot of that is driven by whether or not it's a regulatory inspection and if a certified inspector needs to be involved. And it also, you also can consider the specific inspector you're working with as well. Each inspector is working under their own certification, and they may have their own personal kind of process and things that they like to see. So working with that person ahead of time during the scoping process is very valuable. And if you can, conduct a walk down and drawing review. And with that, if you can get any photos from previous internal inspections, it's very helpful. It helps you understand previous issue areas and helps you better understand the internal layout of whatever it is you're inspecting, so that you can plan from there. And that takes us, once we understand the scope of the job, then we can start to determine what technology is best suited for the task. So a couple things you want to consider: entry point size and location. So if we're talking about the Elios 2, the size of the entry point and actually the size of passageways within your target area is important, because the Elios is, I think it's somewhere around 15.5 inches as a sphere, I believe. And so, we always say you want an 18-inch opening if possible, to make things as easy as you can to get in and out of. And then the location of that opening. So if it's your entry point to the vessel, is it a top entry point? Is it a side entry point? All of these will go into kind of factoring in with your risk assessment, which we'll talk about soon. So what's the path that you have to take, or distance even, from the entry point to the target? That'll help you determine your technology. So for example, if it's some piping that is a kilometer long or a mile long, then when looking at the Elios 2, now you're considering the range of the aircraft with regard to signal strength and battery life and things like that. So in that case, maybe a crawler is best, but then you got to go to your first point again. Is the entry point conducive to that? So obviously there's a lot of things that need to work together here. So total area to coverage during the inspection. So when you're looking at taking the Elios to an inspection, if you have to cover the entire shell of a 200-foot diameter tank, you might want to have a lot of batteries with you. Air movement within the structure. So a lot of times when entry is made or when a vessel is open, they'll put air movers in there to clear out the environment. And you may have options there, since no one is making entry and the area is clear, the gas testing is clear, you may be able to remove those, but air movement can sometimes cause a challenge. So you want to consider that. Data resolution requirements. This kind of goes back to working with your inspector, or if you are the inspector, understanding what the technology can provide based on the resolution you need. So if you need to see, you know, a 32nd of an inch or a pencil line, essentially, you want to make sure that your technology can bring that. The Elios 2 does a great job if you're able to get it close enough to the target. And then finally, the environmental considerations. There are not many, if any at all, options available out there today that are intrinsically safe. So in general, if it's an explosive atmosphere, you'll want to plan ahead to make sure that the area is clear or inerted. Lighting, are you going to need external lighting, or does your technology have sufficient internal lighting or onboard lighting like the Elios 2 has? And then how much dust, ash, and particulates will you be dealing with inside your vessel? When it comes to air movement, we're not only talking about air movers and external air movement devices like that, but the Elios 2 moves a lot of air itself. And so those are also things we'll want to consider. And if you can minimize, one of the things that we ask for, if possible, is you know, if they can essentially water down the vessel if possible. So once we've determined the technology that we're going to use, we kind of go into the risk analysis and mitigation planning. So in our example, we are talking about using the Elios 2 here. So you want to start off with asking yourself the question, now that you understand the scope well, you understand exactly what the area to be inspected looks like and the challenges that are in there. So now ask, what could go wrong, and what are my options if it does go wrong? So with regard to obstacles in there, are there obstacles inside that we can get stuck on? Are there probes that could go through the cage and hit the propellers, or cause the drone to get hung up? Are there triangle areas that the drone could get wedged into? If so, that's fine, but how are we going to deal with that? Whether it be from just a piloting, we're going to stay away from these areas, or we really need to get data in those areas, so we're going to push it a little bit, but what happens if we do get it stuck? Do we have an option to get it down? And in the case of equipment failure, technology sometimes gives us issues. So, if we have a battery fail or electronics fail, or we lose signal for whatever reason to the drone, in the Elios case, well, it's as an aircraft, it'll safely descend and land straight down. And so this takes us to our next point, recovery points, and a plan to do so. So if the drone does go to the bottom of the vessel, can we go in there and get it? Can we rig up a fishing pole to get it? Will we have to send in a rope access technician to get it, or maybe build a scaffold? Who knows, but it all kind of goes into the planning. Another thing to consider is, can the inspection tool, or can the Elios be damaged in the environment I'm putting it in, or can client equipment be damaged? We've been in cases or situations before where the vessel was glass lined, and so we really wanted to make sure that if there was a failure and the Elios fell, essentially, which we've never had happen before, by the way, but if it did, would it damage the glass lining? So something you want to consider. And then, are there any chemicals present, whether that's in the form of gases or residues we run into quite often? You want to make sure that it won't start to damage your tool. Whoops, there should be a environmental and safety check slide Zach. Oh, there we go. Yep, cool.
Sorry about that.
And so that kind of moves us into the environmental and safety checks. This is something that typically would happen right before you insert the Elios 2 into your structure. So before you get out there, or while you're out there, of course, we generally require that safe work permits are complete, and you complete what we call, or at least what the energy industry in general refers to as a job safety analysis or a job hazard analysis. Once all of that is complete, that's kind of prerequisite to get started. Gas and chemical testing prior to inspection, prior to putting the Elios 2 is very important. You know, we have a lot of cases where, you know, hey, this vessel should be clear. You know, we did our normal process to clear it. It should be clear, but because we're not putting people in, sometimes, you know, sometimes things get lax, for lack of a better term, and you want to make sure as the operator to make sure that you get your chemical testing, your gas testing, because the risk is great if the drone experiences you know, certain chemicals that could damage it, and also of course, if it's an explosive environment that was inerted, there's obvious implications there if there's LELs left. The other thing is to test your drone prior to insertion. So just doing a quick test flight outside the structure, you want to find out about issues where issues aren't going to cause you very much issue. So you'd rather find your issue outside the vessel versus inside the issue. And even things like transport. We fly our drones on airliners all the time. We ship them, and lots of gremlins get involved when you deal with shipping, unfortunately. So make sure you check your equipment on the other end, and then always use checklists. The Elios 2 included checklists are great, but we also like to use additional checklists to cover additional things as well. Now we can go on to the data validation. So once all that's done and you've got your Elios 2 in there and you've got all your data, you want to make sure that all of the data has been stored, especially on big jobs. Periodic checks are a great idea. You've done a handful of flights. You want to make sure that all of your data is saved, and it might even be a good idea to back that up prior to doing your next set of flights. If something does happen to the drone while it's in there, it's always a good idea to have your screen recorder on, so you have a lower resolution backup, but checking your data periodically and backing it up between, you know, some number of flights is a good idea, just in case. Once you're finished, you've got all your data. We always like to conduct a review with the client or the inspector, whoever's interested, just to make sure we got everything. And we're always ready to go back in case, not only in case that we missed something, but it's in case that we saw something very interesting that we could see on the high resolution video on our laptops in the office that we didn't quite catch on the lower resolution feed out in the field. So very good idea, just to make sure you've done a complete job before leaving the site. And that's a high level kind of work process, best practices, if you will. From there, I'll turn it over to Zach.
Awesome, thanks so much, Nick. We're gonna go into the Q&A in just a moment, but quick note, if you're just now joining us, and Nick, I don't think there was a way for me to tell you this an hour ago, there was an issue with GoToWebinar and time zones. So if you're just now hopping in and you're confused about why it seems like we're toward the end of a presentation, it's because GoToWebinar mismanaged the fact that in the US we went ahead an hour last Sunday, but in Switzerland that did not happen. So our apologies if you're just now joining and you sort of missed what we just talked about. The good news is please stay on, because we're about to do a Q&A. So if you have questions about indoor drones or indoor inspections, we'll answer those questions live right now. And the other good news is everything was recorded. So It's not in the order you probably ideally want, but we can do the Q&A right now with everyone who's joining, who may have been a victim to the GoToWebinar time issue, and then you'll get that recording after the session is over, so that you can see all the presentations, all the content that we just made. So please accept my apologies, really on behalf of GoToWebinar. It's sort of an unavoidable situation with the time issue, but we are really excited to have you all here, and we are about to do a Q&A, and we're going to draw from Nick's expertise. So again, today we're talking about how indoor drones are being used in the field. We've already gone over some case studies, some best practices. That's what Nick was just wrapping up. That recording will be available within the next few hours. You'll get it in your email, your inbox. But now we're going to go ahead and go into a Q&A in just a moment. I have a few other things I want to share. So this webinar is part 3 of a 6-part series. As I mentioned at the beginning, if you were here, we've already talked about the benefits of drone inspections, insourcing versus outsourcing your drone program. Today we drilled down into internal drone inspections. Next time we're going to be talking about external drone inspections. And then the last 2 webinars of the series, we're going to look at data management. And then finally, we're going to look at data localization. So how to pinpoint the location of defects that you find in your visual data that you collect by drone. Those are all upcoming. Please please join us. Those will be held at the time that we tell you they will be. We apologize again for today. Another note, MFB Rentals is our partner in this webinar. If you are located anywhere that you see on the map that's appearing right now, and you want to buy any kind of RVI, remote visual inspection solution, MFB Rentals probably has it. And I'm sorry, they really are MFE. MFE, I think, is just the name now, so apologies for that. But you can see we have locations in Canada, MFE US. There's a lot of locations, and then there's also a location in Mexico. These are all certified exclusive resellers in those locations of the Elios 2, but they also have a lot of other robotic solutions that you can use for inspection. So if you want to buy something, or if you're just looking for consultation about what you might want to buy, that's the place to go. If you're curious about using RVI in your inspections, whether they're internal inspections or external, Nick's very graciously offered to give anyone who's seeing this a free consultation. So feel free, use Nick's email. It's up on the screen. Reach out to him. He'll consult with you if you want to know, I have this kind of situation. Do you think RVI could work? And he's got a lot of experience to draw from, and it's pretty, again, gracious of him to offer his time. So if you do reach out to him, we're just asking that you include the words free consultation in your email subject line so that he knows why you're reaching out. And in the body of your email, just try to give him some details. I work at a power plant. We're looking for, this kind of need. We have these kinds of assets. The more specific you can be in that email, the more Nick can help you when it comes to the consultation. But don't be shy. Please definitely feel free to reach out to Nick. So all that being said, we're going to dive into the Q&A now. Last thing you'll see on this screen, there's some email addresses up there. Again, Nick's is up there, but you'll also see mine if you have questions about the content or really anything at all, flyability, content related, reach out to me. And Johan is he's in charge of sales for North America. So he's another person you can reach out to if you have questions about the Elios 2 specifically, or reach out to MFB Rentals. Really the same difference if you're looking to buy an Elios 2. All that being said, let's take some questions. Okay, so Nick, you've probably run into this. We actually did an entire webinar about battery life and how to get the most out of your battery life, but we had someone asking, is 10 minutes battery life, which is the battery life for the Elios 2, is that enough to conduct an internal inspection? Can you speak to the limiting factors of battery life a little bit, Nick?
Yeah, absolutely. I understand the question very well. It does not seem like a long time. However, you can cover a lot of ground in 10 minutes with the Elios 2. One of the ways I look at it is you're recording a video essentially. So even if you're trying to cover a ton of ground very quickly, you fly past quickly, all the data is captured at 60 frames per second. You look at it later. You're essentially taking a photo every 60 times a second. So in 10 minutes, that's a lot of data. And we actually haven't experienced the flight duration as a limiter. But with that said, we make sure that we take more than enough batteries so that we can come out, do a battery swap, and go right back in.
Got it. Thanks. And as I mentioned, we did an entire webinar on mitigating battery loss, so different strategies to get the most out of your battery life, and looking at it through the lens of the Elios 2's battery life, assuming that you had a 10-minute battery life. So if you're interested, you can find that in our webinar recordings on the Flyability website. Next question. So this is an interesting one. Is it possible to install Atex motors on the Elios 2? I'm not familiar with there being Atex motors, but Nick, this is definitely for you.
Yeah, and to be honest, I'm not. I don't know of everything that's out there in the world that is Atex certified. However, it's not just the motors. The motors are brushless, so versus the old brushed motors of the past, there is no spark generated. They're basically driven by electromagnetism. So there's no spark in the motor anyway. But there's a lot of other electronics and batteries and connections that are on the drone. And we have seen technologies that are not drone technology, but other technologies that are Atex Zone 1 certified. However, most of the applications we see require an Atex Zone 0 or what we call Class 1 Div 1 here in the United States. If it's a known explosive, in most, I'm guessing the motors you're talking about are Zone 1 certified for non-known explosive. I think, again, I'm not really an expert on that, but that's from my understanding, that's what I know.
But that is helpful, Nick. Thank you. I do want to say, because we're having some more people join and asking this question, again, we are toward the end of the webinar. We know that GoToWebinar was telling everyone that we were supposed to start 6 minutes ago, while telling some folks based on your time zone. So due to a problem with GoToWebinar, we started an hour and 6 minutes ago. So again, our apologies, but if you have questions, we are answering questions right now, and the recording of the presentation Nick and I did will be sent to your emails within the next few hours. So please hang out, ask questions. If you do have questions, we're here to answer them. And please also accept our apologies for the confusion with the time zones. We have a question about 3D models, Nick. Someone's asking, can you use visual data from a drone like the Elios 2 to make a 3D model, and what are the limitations and the accuracy of 3D models if it's possible to make them?
Yeah, absolutely. You can make 3D models using the Elios or any camera for that matter, using various softwares. There's several software platforms out there that can help you do that. I believe, and I don't know if it's limited to, but I do know that the Elios 2 is compatible with Pix4D. That's what we use. And there's even a mode on the Elios 2 that gathers data such that it's very conducive to making these 3D models. The accuracy / resolution of the model will depend on basically how close you can get to your target. So it's a function of the essentially of the resolution of the camera, which is fixed. The part you can control is the distance. So it's a function of the resolution of the camera and the distance away from your target, which is going to give you your resolution, which can, in photogrammetry, can be tied to your accuracy in some ways. So you can get very high resolution data though with the Elios 2 because you can fly very close to your targets.
That's really helpful. And one other thing to mention, depending on the motivation for creating the 3D model, we just rolled out a new software called Inspector 3.0. It's the 3.0 version of our Inspector software that goes with the Elios 2. It has the capability of creating a sparse point cloud that shows you exactly where your points of interest are. So if you notice defects when you're reviewing the visual data from your flight, like for a sewer inspection, you notice there's a crack in a pipe that you'd like to know exactly where it is so you can go back to maybe perform maintenance. The point clouds you can generate using Inspector 3.0 give you that locational data. We call it data localization. They're not going to give you that pretty 3D model that you'd get with Pix4D or a similar software. They're really just a nitty gritty, I want to know where this specific place is that I see in my visual data. So if for inspection purposes, you need to go back and maybe perform maintenance, our software can help you with that. Again, it's not a 3D model, but it can serve that need if you're wanting to localize your defects in your visual data. Well, I'm not sure, Nick, if you'll know about this, because I'm not sure if you work in these kinds of situations, but someone's asking, I think it's David is asking, do cargo oil tanks, like the one that I reviewed in one of the case studies, do they need to be gas-free and vented before a drone can fly in there?
Yeah, so in general they do. So the key thing to understand is that the Elios 2, or and for that matter, I don't know of any drone that is intrinsically safe. And so what that means is you would have to vent to make sure that there are no LELs present in the tank.
Got it. Thank you. We have a question from Angela who's asking, does steel affect the signal for the drone? I guess there's a lot of structural steel in the place where Angela works. Do you happen to know?
Yeah, that's a great question. So many drones that use what we call a magnetometer, or basically a magnetic compass, do not like to be surrounded by steel. They typically throw errors and in a lot of cases won't even let you take off. The Elios 2 is different in that way. It doesn't rely on that type of system, and so it's not affected. And in fact, we fly it inside of steel structures all the time.
Awesome, thank you so much. Let's see. Oh, could you speak to the dust-proof lighting that comes with the Elios 2? We have someone really interested in how it works and also interested in how you've used it, if you have used it, Nick.
Yeah, we use it all the time. It's a great feature. So I always use the analogy because I'm from some of the northern states. Not anymore, but I grew up in a state where snowstorms and things like that are prevalent. So hopefully this example hits home for some people anyway. But when you have particulate in the air and you shine a bright light directly at it, or if you're driving down the road in a snowstorm in your car and you turn your bright lights, or even in a rainstorm, you turn your bright lights on, what happens is you get direct reflection from the particulate, the rain or the snow or whatever it is, the dust. So what's been integrated are basically oblique lights, so lights that shine from the side that are not basically direct, that when that lighting hits the dust and the particulate, the reflection doesn't go straight back into the camera, basically. Kind of like the way fog lights work on a car. They're low, they're indirect to your sight line, and it makes it appear as though a lot of that dust and particulate it makes it disappear essentially to the camera. So it's very effective, and we use it all the time.
Excellent. Thanks so much for speaking to that. Let's see. Oh, this is a question related to the question about Atex. Is the Elios 2 Atex rated? Are there Atex rated drones in general?
The Elios 2 is not Atex rated. I would have to defer to flyability for official word on, if they're doing anything there or whatnot. But it's not currently Atex rated. To my knowledge, there are no Atex rated drones. I know that there was a company in France for a while working on one for external inspection. I've lost track of that. I'm not sure where they're at with that, but it hasn't been released in a big way, to my knowledge.
Yeah, to my knowledge, it's never going to happen. We did a webinar on whether there are any intrinsically safe drones. The short answer is no. I certainly am no expert on Atex, so I wouldn't want to go any deeper on the topic, but um, I think it's a chimera. It's not a real thing. I know that we're not pursuing it anyway, so I wouldn't want to speak more on the subject. Again, it's not my expertise, but yeah, thanks, Nick.
Yeah, we looked into it a long time ago. It's an extremely challenging proposition. I will say though that although it can limit in your applications, it doesn't have to. We just need to, we need to work other avenues to get the Elios into those types of situations. So
Yes.
if it's an internal inspection, we make sure we vent, we inert, maybe we do a nitrogen purge, things like that. There are typically things we can do. Yeah, it adds to cost in general a little bit, but you're still, you're still getting the value of remote visual versus, putting people inside, and hopefully you're not building scaffold and doing rope access and things like that still. So.
Yeah, excellent. Thank you. We have a question about sewer inspections that I'll actually be happy to field. We've had a few sewer inspection questions. So Mason is asking about the stability of the Elios 2 when entering sewers with foul water. So the stability is quite good. We've flown the Elios 2 in large diameter pipes that have incredibly fast water moving through them. Although you could feel the air current from the moving of the water, right? You could feel that there was a fair amount of turbulence in the air from the water, but it didn't ultimately impact the ability of the drone to fly in that pipe. And we were able to complete the inspection, complete the mission, get all the visual data needed. So we haven't seen any issues with using the Elios 2 in sewer inspections, assuming that you have a big enough entry point, and the drone's not very big, so you don't need a very big one. You can get the drone in there and you can get the visual data that you need. Let's see. We have a question from Thierry. So Thierry arrived at the time the GoToWebinar told him to, and apologies again if you're in that boat today, but I'm one of the people who just came in. I don't have the full context. The question is, does the drone need to be decontaminated when working in certain environments? This is definitely related to topics we've already covered, right, Nick? But I don't think we've specifically talked about decontaminating the drone. We've talked about removing volatile substances from the space you're going to inspect, but can you speak to decontamination and whether that's necessary?
Well, I mean, I would say it's necessary if the drone gets contaminated, right? So there's a couple different things to say on this. One is, before you even go into a situation where the drone could become contaminated, and this is outside of what I want to nuclear energy. So I can't speak a lot to use inside of nuclear plants and radiation, but outside of that, you want to ensure that nothing the drone could come in contact with or be contaminated with can harm the drone, unless of course the inspection is valuable enough to where the cost of the drone is okay to experience, basically. But we've had situations where we've gotten some residue on the drone, which was okay for a short period, so we basically dismantled to an extent, which is very easy to do. Cleaned it with the solution that we were provided for decontamination, and the drone's been stored and used many times since then, and it's great. There are other situations for like clean water inspections and for food grade type inspections to where basically the regulations don't allow for decontamination if it's been in, let's say, an oil tank. We'll never be able to put it into like a clean water service inspection or something like that. For that, you'd want to have a new inspection tool and something that you keep only for use for that service. If I don't know what direction you were going with the question, there's lots of directions you could take it, but hopefully that provides a little insight.
Sure. No, yeah, that's incredibly helpful. We have another question. I think you and I can both kind of take this one, Nick. Keith is asking, are the drones limited to visual inspection, or can other NDE, NDT techniques be added? So what I can tell you is the Elios 2 has a visual sensor and a thermal sensor. So those are the limitations for the Elios 2. I'll also say that we're aware of the need to add other data collection methods, and it's certainly something we're interested in doing and working on. I can't really go into more detail, but there are drones that allow for other types of data collection. Nick, have you used any other kind of payload, any other kind of sensor on a drone?
Yeah, so currently we're using a drone to deliver ultrasonic thickness, UT, and phased array, and also a type of acoustic sensor for concrete. So essentially to duplicate hammering of concrete. And that's on a flying machine, a drone. When it comes to other robotic platforms for remote inspection, there are a lot of different NDE tools that have been integrated on different types of robots, crawlers, and things like that.
Awesome, thank you. And it's also worth saying that from a drone industry perspective, drone technology is always being developed to meet the needs of the end users, of the people using them. So if you think a drone can do it, reach out and tell us, because we want to make it for you. It might not happen overnight, but email me, email someone on the flyability team or at the company that you want to work with. If it's a different drone company, tell them what you need and they'll probably try to make it for you. So a question from Angela again about flying in mildly corrosive environments. She says, I'm imagining an application where a tank has been holding a corrosive solution that can impregnate the steel. So to prevent a confined space entry, would sending a drone in gradually corrode parts of the drone, or can the drone be protected from that?
So in cases like that, I guess the example I have is flying in various acid tanks. What we like to do is, if we're faced with something like that, we like to take a look at the SDS for the chemicals and kind of understand the chemical more and what we're dealing with. And in some cases, we even make a call back to the manufacturer of the drone. So in this case, we'd give flyability a call and kind of talk it out together to see what parts of the drone could it affect, and how could we, maybe going back to the decontamination question, if we do put the drone in there, can we decontaminate safely so that it doesn't affect the drone long term? But in the acid tanks that we've been in many times, there's always usually residue left over. So we try to be very careful and not make contact with the structure.
Okay, excellent. I think we have time just for one more. We've already gone over. But I do want to say, this has been a strange and unique time where we have a lot of people joining and graciously staying on to ask us questions. We are available by email. Please reach out to us if you have questions that we weren't able to answer today. Nick and I are both very excited to answer those questions. One other thing I want to say before I answer this last question, or before we do our last few questions, if you guys can check out the slides again, the screen I'm sharing. If you missed this, Nick offered to do a free consultation with anyone considering using RVI, remote visual inspection tools. A drone is an RVI tool, so is a crawler, a robot, any tool that you use. It could literally be a camera that you drop down, through a manhole to collect visual data. So if you are interested in using RVI tools, Nick is an expert. He especially is an expert in using drones, and he's offered to consult with anyone who's interested. So if you're interested in taking Nick up on that, on a free consultation on whether RVI might be a good fit for your inspection needs, whether it's internal or external inspections, please feel free to reach out to Nick using the email you see on the slide. And again, make sure you identify free consultation is what you're pursuing and what you hope to get out of talking to Nick. So just a reminder that that's an offer that Nick's throwing out there. I think pretty generous of him. I mentioned it maybe 30 minutes ago, but if you hopped in right on the hour, you may not have seen it. All that being said, one more question that I think I can answer about how we develop drone technology. We got a question saying, do you look at applications and then develop drones to meet specific applications and needs, or do you sort of develop a universal drone? The question is kind of. So in developing the Elios 2, we wanted to make the best inspection drone for internal scenarios that we could make. And to do that, we went out, we talked to people like Nick and a lot of other inspectors who said, this is what we need to make this drone an actual replacement for my need to enter a confined space. So we had the first iteration of our drone, the Elios, which allowed you to go into a confined space and collect visual data, but it did have some shortcomings that the Elios 2 overcame. One is stability. The Elios 2 is incredibly stable. The Elios 1 can kind of roll around. The Elios 2 also has a feature called distance lock, so you can lock in, like if you want to follow a weld all the way across and know that you're at the same distance the whole way, you can lock in that distance and know that you're doing that and be stable again as you fly. The Elios 2 is also easier to fly. That was another note that we got from inspectors. And then that dust-proof lighting that Nick spoke to, the oblique lighting feature that sort of mimics the ability of an inspector, if they're physically present, to move a flashlight around to make a surface more textured and three-dimensional, see pitting or grooves in the surface. The Elios 2 has lighting that can do that, the oblique dust-proof lighting. So we didn't necessarily go to oil and gas and say, what's the best oil and gas internal inspection drone? And that's because a lot of these assets are pretty universal. Like if it's a boiler, if it's a tank, the needs are going to be pretty much the same if you're entering that scenario to collect visual data. So when we're developing our technology, we're really more looking to inspectors to inform us. We're not necessarily, we're fairly industry agnostic. That being said, there are some needs for specific industries, and we're trying to work to address those needs sort of as we go. So like I said, the answer is kind of. Nick, do you have anything else that you'd like to say about internal inspections before we kind of wrap things up today?
No, but just a quick comment on that, on the last one, if I may. One of the things that there's a ton of technology out there now, but there's a lot of room to grow. There's tons of applications that we as an industry, a remote visual or a drone service provider industry still need to tackle. And so when it comes to this, again, thanks for letting everybody know about the free consultation, Zach. I encourage everyone to reach out to me if you have applications that don't fit a current technology. We can also help, maybe even develop technologies for that. We work with partners like Flyability, just like we did on the Elios 2, to further develop the technology, or build it from scratch, even if it doesn't exist, as long as as long as it's commercially viable. But again, we do that by understanding fully the inspection, engaging our professional inspectors around our company, the SMEs, engineers, et cetera, because the goal is to be able to replace what a human does as effectively as possible, so that we can realize the most value out of that tool.
Excellent. Well, thanks, Nick. I know this has not been your usual webinar. I feel like no webinar ever runs completely smoothly, but I think this may have been the biggest hiccup I've encountered, where the platform sends out the wrong time for the event to some people and not to others. So if you joined us late, again, apologies, but I do hope that even if you were just here for the Q&A we just did for the last 30 minutes, you got some good information out of that. Please know we're sending out a recording that's going to go out soon. And again, reach out to Nick if you are looking for a consultation. And last thing, if you're looking to buy a drone, reach out to MFE Rentals. If you're in North America, in Canada, obviously US and Mexico. If you're international, you can go to the Flyability website, and there is a list of distributors that show you locally where you can find throughout the whole world, wherever you're located. We have relationships all over. So if you're looking to buy an Elios 2 or other robotic solutions for inspections, go to the distributor website or the distributor page on the Flyability website and investigate further if you're not located, where MFE is. So yeah, thank you so much, Nick. Nick has done 2 of these in a row with us. He's a rock star presenter. We're lucky to have had him again. Thanks to everyone who joined us, and we'll see you next time.